Today we want to talk about graphing inequalities. Before we take a look at a couple examples, let's get some notation out of the way. First, before, if you had less than or equal to or greater than or equal to, you've symbolized that with a filled in circle. However, we're going to be graphing functions in this section, so we can't just use a dot or a filled in circle anymore. In order to do that, we're going to use a solid line. So it's pretty much going to look like everything you've graphed since you've started graphing. However, if you have less than or greater than without the or equal to attached to it, you've used an open circle to indicate that. However, again, since we're using functions, we can't use an open circle, so we're going to use a dashed line. So when you make your graph, instead of putting a solid line, you're going to put a dashed line. Now let's take a look at an example. If we want to graph the inequality 2y plus 4x is greater than or equal to 12, this looks pretty close to the equation of a line in standard form. So let's use that to help us graph our line at least. To begin, we can just ignore the inequality, and if we graph 2y plus 4x is equal to 12, this would look like a line that we've graphed before. We would find our y-intercept, and we know that at our y-intercept, our x is equal to 0, and we plug 0 into our equation, and we get, when we solve, we get y is equal to 6. Now if we want to find our x-intercept, we know that y is equal to 0. Plug back into our equation. We solve for x, and we get that x is equal to 3. Now we come on our graph, and we plot those points. Now that we've got those 2 points plotted, we would be able to draw our line in the equality case, where 2y plus 4x is equal to 12. However, we're dealing with an inequality, so now is when we need to start paying attention to that inequality again. We have that 2y plus 4x is greater than or equal to 12. So when we make our line, we want to use a solid line because we have the or equals attached to our inequality. So just like we've always done, we draw a line through the 2 points, and we're almost done here. What we just drew is what we call the boundary. So if you ever hear us talking about the boundary, this is what we're talking about. This will be the function that is kind of the boundary between what is a solution and what's not a solution. So now, if we were to just plot this line with 2y plus 4x is equal to 12, we have found all of the solutions that make this true. However, we want to take a look and make this inequality true. So we're going to have a lot more points that will do that. So How do we know what points are included and what points aren't? Well, let's check. Let's check with the point 0, 0. Now I like to pick 0, 0 because when I plug that in to our inequality, we're going to get 2 times 0 plus 4 times 0 is greater than or equal to 12, which when we simplify that gives us 0 is greater than or equal to 12. Now is this true? Absolutely not. 0 is not greater than or equal to 12. So when you check a point, such as 0, 0, and it's not true when we have our inequality, then we want to shade away from that line. So if we were to shade to 0, 0, we would include it. So we're going to shade all of these points and this whole area away from 0, 0. Be careful when you're checking. You want to make sure that you check a point that's not on your boundary, because since your boundary will satisfy that inequality, then we need to know which direction to shade. So when we ask for this type of graph, this is what we're looking for an answer. We want to see your line and we want to see your shading. Let's take a look at another example. Let's look at the inequality y is less than x plus 3. Now this looks a lot like slope-intercept form of a line. So we don't have to find our x and our y-intercept. Our y-intercept is given to us at 3, so let's plot that point. And let's use our slope of 1 to draw our line. We'll just plot some points here so that hopefully I can draw a semi-straight line. Now, we need to pay attention to our inequality. We have less than, not less than or equal to, so here's where we use a dashed line when we're drawing our line. Now, when you're given an inequality in slope-intercept, you can always check a point. This will always tell you which way to shade. So if we pick 0, 0, we would get 0 is less than 0 plus 3. Always true. So by checking our non-boundary point, finding a true inequality, we would shade towards that point. However, if it is given in slope-intercept, and this is only if it is given in slope-intercept, you can take a look and you can see that it's less than, so you're going to want to shade below the line. So we shade all this area down here. Now if you don't want to remember that and you always want to check a point, that will 100% always work. But if you want a little shortcut that may work sometimes, if you know when to apply it, it'll help you out. Let's take a look at one last example here. The inequality y is greater than absolute value of x plus 3. From last chapter, you should know that this is the absolute value graph shifted up 3 units. So we're going to move our vertex up to 3. And now, paying attention to our inequality, we have greater than absolute value of x plus 3. So we have to use dashed lines when making our graph. So now, let's pick a non-boundary point, 0, 0 again. Is 0 greater than the absolute value of 0 plus 3? So is 0 greater than 3? No, so we want to shade away from that point. So it's going to be everything that is inside our absolute value here. Alright, hopefully you learned something about graphing inequalities. If you have any questions, feel free to let me know.